Hello students, we are going to discuss very important topic in atoms and molecules, that is mole concept. We know matter has different composition. You see, regarding matter, already we have read in last classes that matter has different composition. Matter may be that element, it may be a compound, may be a mixture. So on the basis of composition, matter may be element, compound or mixture. But all these three kind of matter contain different types of particles. Their particles' nature are different. The nature of particles differ from matter to matter. Let us just discuss one. I am showing one model. Just to see, I have taken these two models. If you see the structure of this model, this is if you see the spheres, that plastic spheres are arranged horizontally and vertically. If you see, it is arranged, just let me show you. It is arranged horizontally and vertically, like this it is arranged. And this arrangement, it contains how many? 9 spheres, 3, middle 3 and the last 3. Total 9 spheres it contains. And this structure is different. And this matter is made of how many spheres? 9 spheres. And the structure is it is the arrangement horizontally and vertically in two plane. It is a two-dimensional plane, horizontally and vertically. But I will show you another model. Just you see, this model, if you see, its arrangement is totally different. Here one it is just placing over another one. Here this is the green spheres, over green spheres, and this orange spheres occupies. One sphere over another sphere occupies, but in that case is different because they all are in same plane. But this one and upper one not in the same plane. So, but if you see the number of particles, here the number of spheres is 3 at the below and 3 at the above. So total is 6. So we can say it is one type of matter consists of 6 particles, and it is also one type of matter consists of 9 particles, 9 spheres and 6 spheres. So composition are also different and structures are different, number of particles are different. So here one thing, so how can you know the number of particles available in the particular substance? Particles may be 3 types. These particles, you can say particles of matter. Already you know in states of matter that composition of matter, particles are 3 types. It may be in that atomic form, either in atom or molecule or ions. 3 forms: atomic form, molecular form or ionic form. Matter consists of 3, mainly made of 3 particles, 3 types of particles, either made of atoms, made of molecules or made of ions. So these 3 types of particles constitute different types of matter. So I can know the number of particles, And what are the mass of the matter? So in the given mass of the matter contains how many number of particles and then what type of particles available, that can be known from mole concept. For example, I will give one example. Suppose you want to take 1 dozen of banana. 1 dozen of banana. 1 dozen of banana means that is 12 number. 1 dozen contains 12 number of banana. So 1 dozen is 1 unit. 1 dozen is indicating is 1 unit. It is a larger unit. 1 dozen indicate 12 banana. So this is also unit. It is 1 unit. But you compare to here 12 banana and 1 dozen, these both are same, but expression are different. 1 dozen equal to 12 number. Similarly, in mole concept, to express the matter into different particles, or to express into mass, or to express into volume, so to compare the mass of substance with its number of particles, with the volume of particles, that can be known from mole concept. And the main thing is, what is mole? This mole, this chapter, mole concept, is very much important for calculating, for solving chemistry problems. It is used in all numericals in chemistry. Without mole concept, without knowing the basic knowledge of mole concept, we can't solve any numerical problem in chemistry. It is important in class 9, class 10, class 11, and also in higher class, in research also. Every field in chemistry, the mole concept is important. So, mole, this star indicate the larger unit. It is the larger unit it is the larger unit to express the quantity of mass. The quantity of substance, the quantity of the amount of substance. The larger unit to express the quantity of mass, that is called mole. It is, you know that the power, the larger unit is horsepower. To express to measure the power of the particular engine, machine, it is expressed in horsepower, HP. HP is the larger unit. Similarly, to express the quantity of mass, how much of mass is available, how much amount of mass available, we can know from mole concept. So, mole is the larger unit to express the quantity of mass. And mole, generally, this mole can be expressed into particles, and it can be expressed into mass, it can be expressed into volume. Mole can be expressed into number of particles, it can be expressed into amount of substance, it can be expressed into volume of substance. Both interrelated. If you know the number of moles of the particular substance, you can know the number of particles, you can know the amount of mass available, and you can know the volume of mass taken. So mole can be compared with the number of particles, can be compared with mass, and compared with volume. There is important formula regarding this mole concept. One mole 1 mole of every substance, 1 mole of every substance one mole of every substance can be, it will be equal to that molar mass. It is also called as molar mass. 1 mole equal to molar mass. Molar mass means molecular mass in gram. Molecular mass in gram. We know molecular weight, molecular mass, atomic mass. So 1 mole of substance in terms of mass is equal to molar mass. It is also expressed as that gram atomic mass. It is also gram. Molar mass means molecular mass in gram. It is also expressed as atomic mass in gram. It is also expressed as, suppose you have taken the substance in atomic form. If the substance contains number of atoms, so 1 mole of that substance is equal to atomic mass in gram. If you have taken the substance which contain in molecular form, that means 1 mole of that substance is equal to molecular mass in gram. It depends upon composition. If the matter is made of atoms, then the 1 mole of substance is equal to atomic mass. If the substance is made of molecule, then 1 mole of substance is equal to molecular mass, that is molar mass. And this substance also equal to N0, or it is called Na. Both are same. What is this value? This value equal to 6.022 into 10 to the power 23 particles. Particles means it may be atom, may be molecule, or ion. 1 mole of every substance is equal to N0, and this number is called Avogadro number. Avogadro's number. This N0 symbol or Na is called Avogadro's number, which, what is the value? It is a very large amount. It is a very greater number. What is the value? 6.02 to 10 to the power 23. Very large amount, because 10 to the power 24, 10 to the power 23 is a very large value, greater value. So 1 mole contains this number of particles. If you take 1 mole oxygen atom, it contains this much of oxygen atom. If you take 1 mole oxygen molecule, it contains this number of oxygen molecule. If you contain 1 mole sodium ion, it contains 6.0 10 to the 23 sodium ion. So 1 mole always equal to this number. And 1 mole is always equal to atomic mass in gram. 1 mole is also equal to molar mass, molecular mass in gram. Depends upon the composition. And this number, this 1 mole, in terms of also, it is called as what? 1 gram atom. It is also called 1 gram atom. 1 gram atom. This is a very important term, gram atom. It is also called as 1 gram molecule. 1 gram atom means atomic weight in gram. Don't be confused. 1 gram atom means atomic weight in gram. 1 gram molecule means molecular weight in gram. It is shortest way, gram atom. Gram atom means that is 1 mole. Gram molecule means that is also 1 mole. So this is very important in terms of number of molecules, in terms of mass. And this 1 mole, it is also 1 mole of every substance is equal to 22.4 liters. 1 mole of every substance means it may be a atom, it may be a molecule, or it may be ions, it may be element, it may be a compound, it may be a mixture. 1 mole of every substance is equal to 22.4 liter at NTP. NTP means normal temperature, that is called also STP, standard temperature. That is generally called as how much? 0 degree Celsius and 1 atm pressure. When the temperature is 0 degree Celsius and pressure is 1 atm means 1 atmosphere pressure, the 1 mole of every substance at this condition equal to 22.4 liter. That is NTP, 0 degree Celsius and 1 atm pressure. So this is the relation with mole with volume, mole with mass, mole with number of atoms. So this is the important formula, there is some important relation with mole and mass, mole with volume, mole with number of atoms, number of molecules. Okay, now how can you solve the problem? Let us discuss some important problem. Problem is like this. Calculate mass. Calculate mass of, we'll calculate the mass of, first bit is 2 moles of water. What is the mass? Mass means weight. What is the weight of 2 moles of water? Second question is that 2 atoms, 2 molecules of water. 2 molecules of water. Okay. Third question, that 2 atoms of nitrogen. 2 atoms of nitrogen. What is the mass? D. 2 molecules of nitrogen. Like suppose you take this thing, we will calculate the mass. We will calculate the mass of 2 moles of water, 2 molecules of water, and 2 atoms of nitrogen and 2 molecules of nitrogen. These are the, you see, if you see, what are the data given? Question is calculate mass. We are going to calculate the amount of substance. What type of substance? In the first question, 2 moles of water. Here is data given is 2 moles. Data given is 2 moles. So how much amount of water is taken? That if 2 moles of water will be given, then amount is how much? If 2 molecules of water, 2 molecules means you think very small particles, water particle that is not visible to naked eye. These 2 molecules of water is how much mass? Very negligible mass, then how much? 2 atoms of nitrogen, that is very negligible, then how much mass? 2 molecules of nitrogen, that is in molecular form, here in atomic form. This is the difference. Then how much mass we will calculate? Let us take first example A. Just you see, 2 moles of water. Water is H2O. Water is H2O. What is the molar mass of water? Molar mass H2O means 2 plus 16, that is 18. Molar mass of molecular mass of water is 18. Yes, it is 18. Molecular mass of water is 18. But you see the formula, 1 mole of every substance. Here substance is water. 1 mole of water is equal to molar mass. Molar mass means molecular mass in gram. So 18 gram implies, if you do it, so 1 mole of water is equal to 18 gram. Because as per the formula, 1 mole always equal to molar mass. Molar mass of water is molecular mass in gram, that is 18 gram. 1 mole water is 18 gram. So implies 2 moles. 2 moles equal to how much? 36 gram. So what is the answer? So 2 moles of water is 36 gram. That means if you are drinking 36 gram of water, that means in terms of mole, how much mole of water you are drinking? 2 moles water. Because 1 mole is molar mass, that is 18 gram. So 2 mole will be 36 gram. Then second question. Is it okay? Then second question. Second question is 2 molecules of water. You see, very important. Here word is used molecules, here word is moles, totally different. 2 molecules of water, that means how much weight of 2 molecules of water. But we know molecules means this term, particles, number of particles is coming. So we know this much of particles, 6.022 10 to the power 23 water molecule. 6.022 10 to the power 23 water molecules is equal to how much? Gram, because question is calculate mass. Here is mole is not required because it is a relation between molecules, that means particles, and mass. As for the question, mass is asked. So we know this number of particles, this number already given, this number is always equal to 1 mole, which is equal to molar mass, which is equal to atomic mass in gram. So it depends upon the question. As it is molecular form, 2 molecules of water. So 6.02 10 to the power 23 water molecules equal to, in terms of gram, will be 18 gram. Because 1 mole of water is this much of water molecule, which is equal to 18 gram. Already know the formula, equal to molar mass. So 1 molecule weight will have much? For 1 molecule is equal to how much? 18 upon this number is short form written as Na. So by Na. Instead of writing 6.02 10 to the power 23, you can write Na. So this is the gram, this much of gram. This is the mass of 1 molecule of water. Because this much of molecule of water equal to 18 gram as per the formula. So 1 molecule will be how much? 18 by this much gram. So implies, as per the question, how many molecules given? 2 molecules. So 2 molecules of water is equal to how much? 18 by Na into 2. Because 1 molecule is 18 by Na, already calculated. So 2 molecule will be 18 by Na into 2, which is equal to how much? 36 by Na. This much of gram. This much of gram. This much of gram of what? Water molecules. So 2 molecules of water contain how much gram of water molecule? 36 by Na gram of water molecule. So this is regarding the calculation of two molecules of water. What is the third question? If you see the third question, let me erase this one. Okay. What is the third question? Third question is that to calculate the mass of two atoms of nitrogen. Here the term used is atom. Atom of nitrogen. When we are using atom of nitrogen, you use atomic mass. When you use the molecule of element, molecular form, use molecular mass. This is very important technique. When you use molecular mass, when you use atomic mass, it depends upon the term. When atom will be used, atomic mass will be used. When molecule will be used, molecular mass will be used. So here you see, calculate the mass of two atoms. Atom means number of particles. So you see C. Answer of C is, as two atoms is asked, we know for N0 atoms of nitrogen. N0 atoms of nitrogen. N0, this much of number of atoms of nitrogen equal to nitrogen means N. N atomic mass is how much? 14 gram. Already you have read atomic mass and molecular mass of element. So N0 atoms of nitrogen equal to 14 gram. As per the formula, this is the Avogadro's number. Avogadro's number of substance in atomic form equal to atomic mass. So N0 atoms of nitrogen equal to 14 gram. How much question given? Two atoms. So one atom of nitrogen equal to how much? 14 upon N0 gram. Then as per the question, two atoms. So two atoms is equal to, will be how much? Into 2. That is how much answer? 28 upon N0. This much of gram. So 28 by N0 gram of nitrogen, this much of gram of nitrogen is equal to 2 atoms of nitrogen. So again I am repeating, N0 atoms of nitrogen equal to 14 gram, because as per the definition, as per the formula, 1 atom is equal to 14 by N0. So 2 atom will be how much? 14 by N0 into 2, that is 28 by N0. This much of gram of nitrogen atoms equal to 2 atoms of nitrogen. So this is the regarding question number C. Then D. What is D? What is D given? What is D? D indicates, what is D? D indicates calculate the mass of, question is calculate mass. Calculate mass of two molecules of nitrogen. Just try to understand. Here it is given molecules. Two molecules of nitrogen. In the previous question, it was given what? Two atoms of nitrogen. Here it directly given two molecules of nitrogen. That means in molecular form. Molecular form means you use what? Will use molecular mass. Already I have told you, when atom word use atomic mass. When molecules word will use molecular mass. So that calculation will be easy and your answer will be correct. For example, here two molecules of nitrogen, weight is how much, mass is how much. So it is two molecules means particles. You see the particles formula. So D answer will be 6.022 into 10 to the power 23 molecules of nitrogen is equal to how much gram? Nitrogen molecule means N2. Mass is 14 into 2, that is 28 gram. We know molecular mass of nitrogen N2 is 28. So 6.02 to 10 to power 23 molecules of nitrogen is equal to 28 gram, because molecules means molar mass. Molar mass of N2 is 2 into 14, that is 28 gram. So one molecule will be same 28 by, what is this value? This value symbol is N0. Use N0. N0 is the symbol, that is Avogadro's number. The large number is taken as N0. So this much of gram. This is the mass of one molecule of nitrogen. But question given what? 2 molecules of nitrogen. So 2 molecules will be 2 into 28 by N0, which is equal to 56 by N0 gram. 56 by N0 gram is equal to, you can write 56 by 6.02 to 10 to the power 23 gram. You can also write in number form 56 by N0 gram, or 56 by value of N0 is 6.02 10 to the power 23. So like this, different types of problem can be solved using the mole concept, using the formula of mole concept. So in the next class, we will work out some different types of problem related to mole concept. Okay? Thank you.